Welcome back to our discussion on operations research. Myself, Dr. Debal Pramanik, Assistant Professor of Swami Vivekananda Institute of Science and Technology. Yesterday, we learned that operation research is a scientific approach to decision making, helping business and organization solve complex problems efficiently. Today, we are discussing the applications of operations research. Some of the industrial, government, or business problems that can be analyzed by the operation research approach have been arranged by functional areas as follows. First of one is financial and accounting. Second one is marketing. Third one is purchasing, procurement and exploration. Next, production management, manufacturing unit, maintenance and project scheduling, and personnel management. These are the basic applications of operations research. Now, the next topic is operation research models in practice. First of one is allocation model. Allocation model are used to allocate resources to activities so as to optimize measure of effectiveness. Mathematical problem is the broad term for the operation research techniques used to solve allocation problem. If the measure of effectiveness such as profit, cost, etc. is represented as a linear function of several variables and limitations on resources are expressed as a system of linear equalities or inequalities, the allocation problem is classified as a linear programming problem. But if the objective function or all constraints cannot be expressed as a system of linear equalities or inequalities, the allocation problem is classified as a non-linear programming problem. When the value of decision variables in a problem is restricted to integer values or just 0, 1 values, the problem is classified as an integer programming problem or 0, 1 programming problem respectively. Next is inventory models. These models deal with the problem of determination of how much to order at a profit in time and when to place an order. The main objective is to minimize the sum of three conflicting inventory costs: the cost of holding or carrying extra inventory, the cost of shortage or delay in the delivery of items when it is needed, and the cost of ordering or setup. These are also useful in dealing with quantity discounts and selective inventory control. Next one is waiting line. These models established a trade-off between costs of providing service and the waiting time of a customer in the queuing system. A queuing model describes arrival process, queuing structure, and service process and solution for the measure of performance, average length of waiting time, average time spent by the customer in the line, traffic intensity, etc. of the waiting system. Next one, competitive or game theory models. These models are used to characterize the behavior of two or more competitors called players competing to achieve their conflicting goals. These models are classified according to several factors such as a number of competitors, sum of loss and gain, and the type of strategy which would yield the best or the worst outcomes. Next one is network model. These models are applied to the management, that is planning, controlling and scheduling of the large-scale projects. Parts or CPM techniques help in identifying delay and project critical path. These techniques improve project coordination and enable the efficient use of resources. Network methods are also used to determine time cost trade-off resource allocation and help in updating activity time. Next one is sequencing model. These models are used to determine the sequence in which a number of tasks can be performed by a number of service facilities such as hospital, plant, etc. in such a way that some measures of performance is optimized. Next one is replacement models. These models are used to calculate optimal time to replace an equipment when either its efficiency deteriorates with time or fails immediately and completely. Next one is dynamic programming models. These models are used where a problem requires optimization of multi-stage sequence of interrelated decisions or decision process. The method starts by dividing a given problem into states or subsystems and then solve those subproblems sequentially until the solution to the original problem is obtained. Next one is Markov chain models. These models are used for analyzing a system which changes over a period of time among various possible outcomes or states. That is, these models describe transitions in terms of transition probabilities of various states. Next one is simulation models. These models are used to evaluate alternative courses of action by experimenting with a mathematical model of the problem with random variables. Thus, repetition of the process by using the simulation model provides an indication of merit of alternative course of action with respect to the decision variables. Next one is decision analysis model. These models deal with the selection of an optimal course of action given the possible payoffs and their associated probabilities of occurrence. These models are broadly applied to problems involving decision making under risk and uncertainty. So, these are the basic operations research models in practice. So, operation research is not just about numbers, it's about making smarter decisions and improving systems. Thank you.